here I am repeating what we said yesterday, because yesterday I felt that we went too fast, better to spend little bit time and understand that. So, I will pick up somewhere. The thing is, technology development is always, nutshell is, there is an existing technology always in some form or other. This is the reality. If you do not agree with me, spend some time convincing yourself what I say is correct. For in life, at any point of time, there is a technology available for a product. Mostly it will be commonly adopted technology. Most of the people, what they do, that is what is technology, including the example I gave of going to a provision store with a list telling I want half a kilo of tur dal and this, that was technology at that point of time widely practiced, just as an example. So, technology is existing. You are going to come out with a new technology, means that new in what way is going to give additional benefit to the end user is the most important starting point. You must always start from end user point of view. He has already got something, in what way is going to be benefited, or what is he going to look for, what is his pain it will get reduced. In different ways you can express all this, but that is how should be the origin of that. Second is, how are you actually going to solve the problem or provide improvements using basic science and engineering. This is the key issue where we come in. Otherwise, we can be an artist. If you are an artistic mind, you can come out with a wonderful poem or painting or whatever it is, but for engineering and science, you have to go through your basics to say how things work. We have been taught, and like I told you, what you have been taught is absolutely sufficient for most of the jobs in industry, for manufacturing, little bit okay for EPCM, but for, of course, if you are in technology development, you really have to brush it up. So, that is it. So, go back to that is what I said in technology development. Caustic soda existing at that point of time, I talked about a process called mercury based making of caustic soda. The logic of that was, it was an electrolysis process. What is an electrolysis process? By using electricity, you split some compound, as simple. Lysis is splitting, electrolysis is using electricity to split stuff. Start with common salt NaCl as a solution. So, in solution, which is solution of water, Na plus Cl minus exists. This we know from science. If you do not know, I mean, if you ask the ancient man, what is this Na plus and Cl minus, he could have talked, he could have seen NaCl solid, but what is this? So, now we have come a long way, because we are in mercury process. Na plus Cl minus exist in solution, stick 2 electrodes, because the electricity has to pass in and out of that thing, two electrodes into that, apply a potential difference, happens, you get the product. So, mercury from that point of view, take that picture and we will start. Yeah, this is a quick picture again. How is it seen? You can see 2 electrodes, one is the vessel itself, the bottom of the vessel itself is the electrode, steel, and then we did a little googly in saying, instead of steel, we added one mercury on it, and mercury is flowing on steel like a small film going through that, and mercury we know is a highly conductive, it is actually a metal, right, liquid metal. So, steel, on top of that mercury is flowing, this is one electrode, because it conducts electrons. The second electron is sitting inside on top, it is a titanium 1 metal, again conductor. These are the two, and you apply a potential difference between the two. Now, look at it very carefully. What happens again here is, the blue thing is a brine NaCl solution, it is saturated, because you want lot of NaCl to come. As it flows through, take a minute before we switch on the electricity, what happens is, steel, on top of the steel there is mercury film, and on top of that there is water containing NaCl. Now, mercury has this habit of not being wetted easily with water. So, at the interface, whatever interface, it is a peculiar interface. If you take a normal steel, dip it in water, take it out, you will find a film of water sticking onto that, because it is wetting, right. Put steel into water, take it out, it wets. Put mercury, it is very close to water, but it is not kind of in contact with water. If that interface, if you take, electron enters, because there is a potential difference, electron enters the steel conductor, jumps on to mercury conductor. Now, mercury electron combination is here, very close to it, but not exactly in contact with it is water. This is very important. and water has Na plus Cl minus ions. At some point of time, quantum mechanics basically, electron decides depending on its energy level, I should now jump into the orbital of sodium. It can also jump into orbital of any other available electronic states. Why only sodium? It can be into anything else, like what other? Cl minus, but Cl minus is already negatively charged. So, for an electron to jump into a vacant orbital of Cl minus is practically you will rule out. So, chlorine is not a candidate. Na plus vacant orbital is a candidate. What else? It is not only to Na plus and Cl minus, there is water all over the place. So, water H2O also has molecular orbitals. Because it is non-contacting with mercury, you can expect that the water molecules are a little away compared to rest, and therefore, electron really decides to jump into the sodium, becomes Na, Na plus becomes Na. The second property takes over is mercury can dissolve Na. So, instantly electronic transfer followed by dissolution of mercury. Dissolution is again a diffusion control process, right. Concentration gradient is what is really makes Fick's law of diffusion. So, it goes into mercury, it comes out. So, this is the picture. Rest of the data I will not get into because we are going to talk only about the electrolysis. Now, this was done because it worked. First of all, you got Na out, and then you wanted basically the whole process was all not on this funda on electronic transfer and your funda was I wanted caustic soda NaOH. So, you got this mercury added with water, reaction takes place, because in this case again if you go to the basics of that, the Na tends to release that electron to water under proper conditions, and in this case it happens. Therefore, Na plus again gets regenerated, OH minus happens, hydrogen comes out of the water present. So, that is the process going on. Critical to whole thing is you can say for this process to work is there are several things which are critical for the process to work, but one of the most important thing is mercury, because if you did not have mercury, imagine you cut off mercury in this and try to operate the mercury cell for whatever it is named, you will not get anywhere, right. So, but mercury we saw there were so called issues with mercury due to a completely different set of events. Mercury was implicated, mercury. So, with that let us go to the second process, membrane. Here I said previous one. So, from here parallel to this there were a lot of R&D just working on, people are working on membranes. I mean I can tell you very clearly they were not saying that okay mercury has to go away from the process and therefore I should, that was not the case at all. Lot of researchers world over were interested in membrane for its own sake. We are talking about 1960s around that period, 50s, 60s in that period, and polymers have been in existence. People play around with it, look at interesting properties of the polymers, membranes, and that sort of thing was parallelly going on. Somebody discovered a membrane that is, this is a slide which I want again spend. This is a property, one of the properties is sodium ions only will go through and no other ions will pass through. Okay. So, this is just a chance discovery. Now, the company which took one of the companies, there are several companies which took patents. I put Asahi because Asahi is a Japanese company and the Minamoto all that was happening in Japan. So, Japan is a hotbed of anyway Japan is a highly creative country even today, lots of was happening. So, from there in this slide last time I made an error I realized, because I was probably making it at 11 o'clock in the night talking about something else. So, the first sentence read, if some of you have checked yesterday, permeable, the previous slide said it is permeable to sodium ions, but when I wrote here as OH minus ions I wrote. I did not realize it in the class. When I went back yesterday night and tried to load it on your Moodle, I said what is the nonsense I am talking about. In the first slide I talked about Na plus, in the second slide I am talking about OH. In fact, there are OH minus permeable ions membranes are also there. There are membranes which selectively pass H plus. You can these days people are developing different membranes for different things, but in this example that last class slide that Na plus should have been there instead of OH. So, we are consistent about Na plus. With that what happens, let us switch, we go to the cell again. Now, we want to avoid mercury, but still have electrolysis. So, I said we put a membrane, the center, this is the membrane there. On one side of the membrane you fill brine. So, there is the brine which comes here, let us say you get brine from here, fill it up in this compartment. It has got what? Na plus Cl minus water. On the other side you put, to begin with, a very dilute caustic soda. It is not compulsory, but it helps for some reason. So, you put caustic soda. So, you got a membrane, on one side I got Na plus Cl minus water, other side you have got water Na plus, because caustic soda is Na plus, OH minus a little bit. We are clear up to this point of time? Any doubts? Okay. Now, you apply a potential, then interesting things happen. Let us, the chlorine part is the simplest part. Cl minus ions, if there is a sufficient potential difference, they will release their electrons, become Cl, life is simple, out, gases go out, that happens, bubbling away to glory. Slowly what happens is, that portion there is a depletion of Cl minus ions. When Cl minus ions gets depleted, then what is remaining is Na plus. So, there is a build up, because Na plus remains there, it does not take place in any reaction, right, it is stuck there. So, Cl minus is going away, this state is tending to become little bit more positive, and this membrane I said is selective to passage of sodium plus ion, this is the critical part. So, because of the fact that there is a concentration indirect build up, you are not adding Na plus, it was there, but because you removed Cl minus, Na plus indirectly concentration builds up, and because of that there is a diffusion, and this membrane happily allows that Na plus only to go through. So, sodium plus ions start coming into this side, Na plus is coming, this part is clear. So, chlorine is going away, Na plus is diffusing and coming out. Come to this part, we have got Na plus. What we should do is, the problem is the electrons that went somewhere, they have to return back to the circuit, otherwise electrical circuit will not get complete. So, the chlorine that got released its electron, that electron you track it. So, it goes, comes to the power source, gets picked up energy and got pushed back to the second electrode. Here there is no mercury, that is the second difference. So, in the previous one we had mercury, here there is mercury, it is just steel plate with some coatings etc. Nickel is used, usually nickel coated with steel coated with nickel, it comes, that electron has to go somewhere. In that mercury case, it first through mercury it went and jumped onto sodium Na plus. Here the potential is so adjusted, it jumps onto water H2O, it does not go to Na plus, because it is very hard for Na plus to pick up an electron. The tendency for sodium is to release the electron, that is why it is a very reactive metal, right. Give me a charge, remove the electron, I become Na plus. All of you will remember that octave rules or whatever, that one electron which is hanging around extra. So, it is a tendency for it to get away and not get in, unless you put a huge amount of energy and pump it back, it becomes. So, here you do not, there is one important point, you do not have to put too much of energy, because there is a ready recipient of electron which is in the form of H2O. H2O, if you again go to your basic chemistry, it is that tetrahedron kind of a strained tetrahedron molecule, one hydrogen here, oxygen and two p orbital electrons hanging out, right. Remember that lone pair of electrons, that is all. So, this is a potential recipient of electrons, and electrons actually jump into water. It jumps into water, I said, because it is possible to jump, this metal water contact is perfect. That is the first, I said, you take a steel plate, dip it into water, take it out, you see a film of water. You dip mercury, no contact. Because of the facile contact of water onto the metal, and the metal is now got an electron at a fairly moderate energy level, electron transfer takes place, and I do not know whether you, I think I do not know how to make it bigger, but I will show right in the top, there is the equation written, you guys can see that, this one. That shows water picks up that electron, and then the reaction takes place is OH minus ions are generated, because oxygen has a preferentially more electron negativity compared to hydrogen. So, it grabs that electron, hydrogen tends to get isolated, and two hydrogen atoms like that join together and hydrogen bubbles out of the gas. Now, in the past, taking sodium and then dumping it into water and making it react with water and getting hydrogen, we have achieved in one single step. with no interference from sodium. Sodium remains Na plus. So, to summarize what happened, sodium transferred from here to here, chlorine went up, electrons came, reacted with water, made OH minus, released hydrogen, hydrogen is bubbling away. So, in a single cell chlorine is coming out from here, hydrogen is coming out from here, and here that OH minus is building up. Because it is building up OH minus and there Na plus is building up on the other side and it is permeable to Na plus lands up on this side, potentially you are making sodium hydroxide, because Na plus has landed up here, OH minus has got generated, you got NaOH, and there is a kind of a circulation system. I initially said you start adding a little bit of caustic soda to begin with, right, I shall explain. It is not compulsory, because you need some ionic conductivity, because this electronic movement we talked about is outside circuit is very simple, pure electrical engineering. Across the electrode to the reacting molecule is reaction, can take Butler-Volmer Nernst equation, but inside the solution for the ions to go here and there you must have some ionic conductivity. So, for getting ionic conductivity on this side there is no problem, Na plus Cl minus water is beautifully conducting. On this side if you had only pure water, actually basically you want only water, right, because that is a reactant. If you had water, electron will pick up, OH minus will come, hydrogen will go, that is all you needed. But since water is not such a hot conductor, to make the conduction process easier, add a little bit of caustic soda, it is like a kick start the whole thing, it does not do, and then slowly over a period of time concentration will build up. Essentially summing up again, what you are getting is water is one of the reactants that comes out, pure water, and this has got to be really pure water. In fact, much purer water compared to the water that is used in the mercury process, because this membrane is a very delicate fellow. You made it in such a manner that it has got this beautiful property of only allowing Na plus to go through, but it is a bit of a delicate fellow, it chooses its company. So, if it has got calcium plus, magnesium plus, aluminum kind of a thing, it will also start interacting with the OH and will precipitate. Therefore, this water is actually purified like mad, simple ion exchange purification, triple ion exchange columns are there. So, you get pure water that comes in. That is also the reason if it is only pure water, horrible thing is its electronic conductivity is even worse, like DM water conductivity is pathetic. So, you need this caustic soda help. So, you put essentially if like see a black box like this, water is put from here, the brine is coming from here, we bringing in NaCl, electricity comes from here, caustic soda goes out from here, hydrogen goes out, chlorine goes out, membrane technology. Okay. Important that we should understand this, how this took place. Now, go back and say all this for what purpose? Because you want some customer to benefit in a slightly different way compared to what he was getting it. The three issue which I said is there was a scare about mercury, here there is no mercury, tick, but that is not the only reason. Second is cost, which is a major reason for inhibition. Why does the cost come down here? Now, in the one of those slides I said if you take the electrolysis process of a mercury thing, the two cell reactions, you know, it is always there is a cell reaction, there is an anode cathode, there are two reactions taking place at either anode, these are called half cell reactions. So, if you take in one side Cl minus becoming chlorine and releasing electron is pretty much standard for everybody, and experimentalists, some guy spent I think 10 years meticulously doing this reversible potential calculations and listed that standard reduction potentials. If you go through in chemistry text, there is the standard reduction potential tables are available for any reaction that you think of, purely experimentally. There is no way you can guess this will be better than that, you can guess, but to get a number no way except to do experiments, and luckily some soul has spent its time and then connected it. You go to that Cl minus, I have given you what is that voltage that is required. If it is Na plus in a mercury, I also given you what is the voltage required. Therefore, the mercury cell required that minimum voltage to be applied, that is what we got. Now, come to membrane cell where the energy saving takes place. Cl minus is Cl minus, you can't expect any change there, that remains. The other half in this case where the electron goes is not going to the Na plus, and remember Na plus hates getting electrons, its natural tendency is that release electron. So, if you want to force feed electron onto that, obviously you have to come with a lot more energy level to push the reaction forward. In this case, we are not forcing the electron onto Na plus, we are forcing the not forcing, we are allowing the electron to react with H2O. You take the half potential of water, I suggest some of you go back, check the standard reduction potentials, you will find it is at a much lower value compared to forcing it on sodium. Makes sense, because sodium is a more electropositive metal. So, and that is the reason in this cell the overall potential difference required is much lower compared to the mercury cell, and that is the reason its energy consumption per kilogram of the product produced drops down. So, you had a motivation of non mercury process driven partly by environment, and membrane was a fortunate development, which membrane which allowed that if the membrane was not there, this process does not exist. How will sodium come from that side to this side? So, that happened. It so also happened that electrochemically that is a energetically more favorable reaction, and hence this became lower cost. So, that is the how this technology worked out. Summary is, after it is worked out, you see the butterfly, it is wonderful, but when the caterpillar is becoming a butterfly, nobody knows what happens. So, it is a bit of a risky messy affair that we got to do something about mercury, something, but the intelligence and the spark is for somebody to realize here is a development of membrane which independently was taking place. Pick up the essential point from there, independently look at the standard electrode reduction potential and say why can't water be absorbing electrons instead of sodium being forced to, and come out with a scheme, first theory TRL 1, 2, 3, and then make that, because this membrane, now I will tell you something interesting about the membrane. Sodium we have understood. Now, on this side of the membrane and this side of the membrane, is the pressure same? Need not be, I mean we do not know, definitely we can say it is the same, you cannot make a conclusion, it could be different. Now, actually purposely it is made in actual practice slightly different. The reason is nothing is 100% leak proof or permeation free. So, this sometimes there is this green stuff on the top, that is a vapor phase, where there is a liquid level, above the liquid level there is some gap, right, whatever we can call it a air gap, in this case air is not there. So, it can a gas gap or whatever you want to call it. So, there is one, on one side you have got chlorine gas, the other side you have got hydrogen gas. It is no reason why they should be same pressure exactly, could be different, and like I said deliberately purposely the pressure of chlorine is kept slightly lower compared to the pressure of hydrogen, few millimeters of water column. You understand what is millimeter of water column? You take a water in a tube, if you keep it let us say 10 centimeters, at the bottom whatever pressure you get is 10 centimeter equivalent water column. Water column is clear, no? Okay. So, you keep it slightly, because in case there is a diffusion of gas through this, it is better a little bit of hydrogen leaks into chlorine. Why? Because if you read the explosive limits of gases, hydrogen is explosive. So, under those small concentration of hydrogen in chlorine, it is not a big deal, it is a wastage of hydrogen, all right, you produced hydrogen, little bit you wasted, but it is not a safety hazard. But if that chlorine entered into hydrogen, which is predominantly hydrogen, little bit of chlorine, if there is a spark, boom. So, from safety I am sure somebody learnt it the hard way, he broke a glass apparatus, then you keep that. Like that there are lot of other aspects. The point I am trying to drive about this is the technology means picking up ideas, concepts, proven stuff from everywhere, stitch it all together with one core idea, make it work holistically, that is technology. One of my earlier thing I said is merely getting a wonderful idea is not technology, it is a wonderful idea, making it together is technology. So, that is the thing I wanted to elaborately go through that. Yeah, today's scenario, last 2 slides, then we will go. Today Asahi Kasei made a very, one of the companies which made a big improvement, and even today they are very active in the field. They are, but then the idea picked up. Now I want to tell this because today there are a large number of companies, means I skipped one intermediate. How is that possible? One fellow invents it or puts it together for the first time, because he what did he invent? He invented that everything can be put together, right, because he did not invent the membrane, he did not find out standard potentials, no, but he got a clever way of putting it together, that is what he did. Now how can other fellows copy? That is because when you go for patenting, you can't patent an idea, you can patent a process of making it, you can patent a product of making it. So patents were taken on how to make that membrane of certain characteristics. Patent cannot be taken, I have a patent for caustic soda technology based on membrane, you can't take a patent, try it. Therefore if one fellow came out with that, the other guys will think, no, it is a great thing, market is picking up, everybody is shifting, costs are reduced. So bring up that membrane, do some tweaking here and there, this is my new membrane with new whatever, you can patent it, and therefore you can make use of it. So that is how the whole thing worked. Today a large number of companies, so much so it is like a commodity. You want to set up a caustic soda plant, I am interested in caustic soda plant, you guys who want to support me, EPCM guys we talked about, come and build it for me, tell me what is the price, what is the energy consumption you will guarantee, what is the capacity you will guarantee, there are 5 fellows waiting in your office, I want to be part of that. So it has come to that level. Now is there any still technology development going on, because the present at that time was mercury, from there delta became membrane, is there a next delta? Who knows, depends on, there is some unmet need of the customer of these guys, caustic soda guys, suddenly they come out with some issue or a problem, if you are in a clever position to do that, maybe you have got a third technology development there, who knows what it is. But what people are parallelly independent of this technology development, what people are working on in terms of research ideas, clever ideas and so on like that. This I skipped one step saying that when you apply electrical potential, electrolysis takes place. We gave some numbers based on standard reduction potential from tables. In reality this how the tables are arrived at is, like I said, thermodynamically stable conditions, which means you put some experiment, slightly increase the voltage this side, current will flow in one direction, reverse it, it will flow in the other, there is a reversibility conditions, which means hardly any current is flowing. Under those conditions you calculate what is the equilibrium potential, but in reality like I said, you need to have a large quantity of electricity flowing, right, because the electricity is what that splits the reaction. So you need as much electricity to flow as possible. So actual potentials will not be like theoretical potentials, there will be something called over potential. This is that Butler-Volmer theory, if you can go through. So you spend more than the theoretical limit a little bit on that, and in order to make that as small as possible, there are catalysts that is put. Famous in chemical reaction also, if you want to speed up the chemical reaction, if you are able to find out a interesting catalyst, same concentration of the reactants, but add the catalyst, it reduces the activation energy, more reaction takes place. Similarly, that electrode potential, which is the theoretical minimum you have to overcome before the electron transfer takes place, if you are able to come out with some coating on the electrode surface, which will reduce the activation energy and therefore improve the kinetics of transfer, you will get higher current flowing through at a slightly or same voltage, or you can reduce the voltage for the same current. Net you will save some energy and you will get more production. When you get more production, the size of the equipment becomes smaller. So hell of a lot of research is taking place on catalysts, on water reduction, because the key is chlorine is one part, water reduction is little more difficult. So you open a research paper today, I am sure probably some 40,000 research papers per year is getting published on electron transfers to water at various conditions, this surface, that surface, this catalyst and all is going. If one of them comes out like a winner under alkaline conditions, reasonable, easy to make, fabricate, coat stuff, you have got a good thing going there. Second is, maybe we should work for a membrane which gives longer life, because these membranes what said and done has some lifetime, not too bad. Typically my experience is after 5 years you have to take out membrane, do some hotchpotch and put it back. If you get during that period, of course the out plant is out, not running, or you keep some stock, change it, plant runs, you repair it, spend some money and bring it back. If you are able to work on longer life of the membranes, then you have got a good thing going. So, maybe lots of things are happening. So, that is the I thought I will show, but since I am going slightly slower, go through this website. This is India's largest caustic soda plant. It is being built in Gujarat. No, not for political reasons. It is definitely a logical reasoning, because Gujarat is one of the largest states where salt is produced by solar evaporation. So, raw material salt is available in plenty, that is one. It is also located in a thick of a place where there are a lot of chemical industries in and around. So, the chlorine that comes out as a byproduct can be taken care of, lots of. So, that is logically you do not stuck with, chlorine you can't store beyond a point of time, then the plant has to be cut down. Third, the caustic soda, which is the main product, this company GNAL is Gujarat Alkalis and NALCO, National Aluminium Company of India, which is a large public sector company. They are India's largest aluminum manufacturers, and alumina, if you remember, the ore for cleaning up you require a lot of caustic soda. So, it so happens the end users of the product are located in and around. So, it makes a lot of sense for them to put up a bigger size plants, that is what they are building, membrane process. So, just out of interest, 800 tons per day. Question is, if there is a fortunate place where similarly there are raw material users, availability as well as finished product users are available in a pack, can we build a 1500 tons per day plant? Means you can, but what I mean by 1500 is a single stream of 1500 you will make, or 2750 you will make, or 3500 you will make. It will depend upon your ability to size the electrolyzer and ensure all that we talked about, mass transfer, heat transfer, bubbling and going away, all that in a small area you can manage, right. You can easily, in a small membrane you can keep it. A room sized membrane, if you want to fix it up, there are other issues. They are also technological issues. They may not be very fancy sounding research, but they are good practical technological issues. So, that is what I wanted to show. What is expected out of this project? Learning objectives I have listed down here is, first of all, you can choose an application area. Application area, because finally technology development, marketing, manufacturing, everything is finally with somebody has to buy it. So, from in order to get the customer's point of view, take an application area of interest to you, whatever application area. Do not take a research area to begin with, because the connection of the research area into an application is fraught. So, you may like it may be interesting, but you may go here and there. So, always start from the reverse end, take an application area first, then refer to any technical paper. Technical paper, please do not take McKinsey's report of what is the global economy is supposed to be in 2040. So, take a technical report, and that technical report should be relevant to the area that you have chosen, not with couple of trial and error you will get to know. Then read the technical report fully to understand what this report is trying to bring an improvement to the application that you have in mind. Now, the connect is very clear. So, you have an application in mind, you read a paper, back of the paper you are not reading the paper as a scientific discovery, that you do it separately. I am not saying discouraging, I read it a lot, but in this exercise keep that as a secondary. From the application point of view, how relevant is it, what is that the fellow is bringing new to that thing, like that you read through that. Then sit back and think, today how is it being happening, because you have an application area, something is being done right now, you know what is most common, you can figure it out. What is the current way of doing things? There may be 4 or 5 ways of current, pick one of them, whatever you like. So, you have got application area, what is currently being done by and large. This guy is coming and saying a new way of doing things, read it, try to figure out what has happened. Then the delta claims, this paper will normally claim I have come out with like that. For example, if you are reading that membrane, if you went back in 1960s, one membrane fellow has said, I have synthesized a membrane as compared to the other membrane, this membrane sodium diffusion potential blah blah blah, something like that. So, now you will read it, but if you have come out with a caustic soda background, you will click. But if you are talking about let us say high density polyethylene, this paper, you will keep it aside, right? You get the link. So, this is the thing we have to go through. Then this is the where you have to analyze the new method, whatever new claims that the paper is claiming, is it ready, is there sufficient information produced by the research paper, by reading it, by referring it, etc., that tomorrow as a reasonable chemical engineer you can start building a plant for the end use. It is not very difficult, it is because if you know already how things are being done, you will have a flow diagram on your hands. Of course, the product is being made, that is why you chose that application area. So, you will know how things are happening. So, you will know like mercury process, brine purification, electrode, all that you will know. So, now this new idea which has come through, that against that superimpose and see is it ready, or if you think it is not yet ready, what more needs to be done for you to get convinced it is ready. Last, after this and only after the 5 steps, look at saying is it likely to be cost benefit, which means benefit part is easy because technical improvement you have to give some number. Caustic soda example is 3000 kilowatt hour, 2200 kilowatt hour, 1400 kilowatt hour savings into 5 rupees. Hey, 7000 bucks per ton of caustic soda is a big deal, yeah, that part. But how much will the plant cost? Impossible. So, do not worry about that, but you can speculate. Like caustic soda example is there is some electrolyzer fancy stuff, then there is the whole thing is flowing into some other reactor where hydrogen is coming out, there is some mercury is circulating. Here it seems to be a pretty compact stuff, just one. Possibly we can't be out of whack, that is enough. One is not actually, in reality you have to put every, like I said, no, you have to make a massive Excel sheet, find the cost, put it, installation cost, all that you have to do, but that comes much later. To get the feel as an engineer is very important. Here 2 large piece of equipment seems to be a simple piece of equipment, not very fancy also. So, we are not, this is it. So, that is what you are supposed to do on the learning objectives. I got 3 more minutes, okay. Rest is all I will fast forward. I am going to post it, so read it, we can even discuss it in the next class. You may be thinking, why is it relevant? Does anybody doubt, is it relevant, this kind of a project for our course? If you have, I will change the project. So, do not answer right now, think through that. I feel it is relevant for these reasons, think through, but like I said, I am very open to, based on your feedback, go back. And now we have to application areas, you have to choose some application area, read a paper. I have got some topics which I always keenly follow. So, I have got a list, I can show you the list, I can give you some papers relevant to each one of them. On the other hand, you can just dump it, pick something of your own idea, okay. So, this also I am going to post. Now, groups is you have got that paper, form groups of that. I have given the steps is read up all this, cover all these points, methodology, key part. This written report should be made available by 10th April by all. So, we are having 2 weeks in February, whole of March, April. 10th is a non-negotiable, not changeable deadline, because after 10th, if assuming I get 5-6 projects of this nature, I need to spend quality time on trying to understand your ideas. Then the way that it is structured is, there will be regular classes like this where the groups will come and then they have to present it to the rest of the class. I would have gone through, I am just only an observer, you will present and rest of the guys must ask questions and everybody gets a turn like that. The evaluation will be, first of all, whether you do it on time, produce a good written report, how well are you able to present it. Your first question, those day first day asked what is the weightage for this and that, we will decide weightages, but the thing is definitely there is a presentation part, because in companies you will have to talk and that. But it need not be a very fancy, the English is not getting evaluated, by the way. You want to make a presentation in Hindi, I know a little bit of Hindi, now I know a little bit of Bengali also, I told you, I can come with an interpreter, forget language, then not an issue. You break half of it into this and no issue at all. So long as you are able to communicate to the target audience, in this case at least to the rest of the class, you are all right. So the presentation is meant for checking your clarity of thinking. So that is the reason for that direct presentation. And recipients, like you have been very silent in this class, please do not be silent in that class also. It is your chance to get clarification from your colleague. Guideline is do not attack somebody, do not try to prove that what he said is wrong and what you say is right. In fact, it will be a negative. I will be watching how well you are able to pose questions to get clarifications. That is the key, because in companies, people toxic culture you have heard of, several companies are given an example. Toxic culture is one fellow comes as a king born to save the mankind and ruins the career of rest of the fellows. It is not at all recommended. What you should do is that in a group of people, when they are talking with multiple interest, multiple talent, how well you understand what the other guy is trying to say is very critical for success. So use a similar context here. This is not one-upmanship. This is not who puts most inconvenient questions to your colleague. That is not the case. It is to know what he talks, have you understood, or for you to understand it better, how do you ask a counter question. So that side of a thing everybody gets to know. And lastly, we will also decide within the group, should everybody get the same grade, or if you come out with some reasonable, transparent method of evaluating, that is also fine. So that is what is going to be the project work. I am going to post it, and then next time I hear about it is only on 10th of April. I joked. I am available as a background for giving you clarification, support, question, because this is not a, there is an answer I have to give, I am hiding the answer with me, that is not the case. I am provoking you to think like an engineer, to come out with ideas and apply whatever you have been told till now. We have talked a lot of ground. How well are you able to synthesize? That is what I am trying to help out. So I will play a very careful role and not giving you, even if you prompt me, is this right? I have the skill to do that, excepting I will say, what else have you considered? So I will kind of direct you to your question to reflect, for you to think for yourself. So you can be very, number of times you want to call me, find some time and do that, this is encouraged. So it is not as if assignment is given today 16th February, 10th April only we shall talk about it. That will not work, especially in view of the first assignment, which is a simple one, heat recovery. I tell you, SO2 put you all in such a complication. So I do not want this to happen. Okay. So that is what it is. We have just 2 minutes above the class. I hope it is all right.